Welcome everyone to this exciting conversation on the intersection of quantum computing and enterprise AI. While quantum computing is still in its early stages, its potential to transform AI is gaining attention across industries. Today, we are joined by a distinguished expert, Sudhir Tiku from Bosch, to explore what this means for enterprises and the challenges ahead and how organizations can prepare for this technological shift. Before we dive in, Sudhir, could you introduce yourself?
Okay, thank you, Eleen, for the opportunity. So I have been in the automation space for the last over two decades of time, and worked across companies across regions, and I'm a very keen student of how technology evolves, and in that sense, enterprise AI and now the promise that quantum computing brings in, yeah, I think can make this conversation already purposeful and meaningful, and I want to contribute here.
Yeah, awesome. All right, so let's start with the big picture. So, quantum computing has the potential to supercharge AI by solving complex computation at unprecedented speeds. While this is still largely theoretical, we are already seeing early exploration in this space. How do you see quantum computing shaping the future of enterprise AI?
Okay, maybe I start with basics and maybe break this down for our listeners and audience, that what exactly is this quantum computing and how does this differentiate itself from classical computing. So typically in classical computing, these are the laptops and the computers and the mobile phones that we use these days. Information is processed in bits, so and the transistors come into play. So a bit can be a 0 or a 1, and this is how the information is encoded, right? So there is either a 0 or there is a 1, and then there's a syntax, and then there's a combination of these zeros and ones, and this is how the information is processed. And we have the famous Moore's law, which kind of guides this processing of information. However, this kind of information processing has disadvantage because there are only two possible states, right? So what about a situation wherein we have not only just two states, but multiple states at the same time? Yeah, and that's where quantum computing comes in, because here we are computing now at subatomic level. We can use, say, atoms or electrons to compute, and then the charm of quantum mechanics is that an electron can be a wave or a particle at the same time, and that's the principle of superposition. That if I explain this yeah, concept of superposition in a simple language, it means that I can be at the two places at the same
At
time.
the same time, yeah.
At the same time, right? And then we have the principle of entanglement, that despite the distance yeah, between two particles, they can still influence each other. This is exactly what gets exploited in quantum computing, is that you have now multiple states. You don't have just 0 and 1. You have
Mhm.
0, you have 1. It can be 0 and 1 together. It can be 1 and 0 together, and it can be multiple states which exist between 0 and 1s, and hence the processing capability becomes exponential. Yeah, and actually the Newton's law, which is a different kind of a law, sets in, and then this makes computation yeah, extremely scalable. And for example, there are theorems in mathematics which classical computers can take maybe millions of years to solve, and with quantum computers it could be few seconds. Yeah, this is when we achieve the potential of quantum computing. So this is just wanted to set the basics, right? That where the scale comes from. The scale comes from physics. Yeah, basically. So now, since we know that computation is now exponential, so what it can do from an AI perspective is that it can do three things. That AI, we train on data sets, and now the speed of how we train AI can assume a different scale, right? So with quantum computing, the time that we are currently needing or we have to train models, that the capacity to train models on high dimensional data, the time gets reduced. So that's number one advantage that I clearly see with quantum computing, that the training profile in AI will change. Secondly, I think AI, as we know, is a game of optimization, right? Basically, the purpose is to reduce the loss function. Yeah, and
Yeah.
that's how the back propagation comes into play. So quantum computing, I think, because of the multiple states that it is capable of positioning itself into optimization through quantum logarithm, quantum algorithms like the Shor algorithm or the Grover algorithm, becomes much more easier. And hence that's why we say that with quantum computing we can solve the puzzle of the origin of life. Yeah, we can find new material. We can see how atoms interact at atomic level. We can do drug discovery. Yeah. Ultimately, the applications that will come through quantum computing are something which is really very inspiring. Or, for example, climate change. Yeah, these are the problems that we cannot solve by classical computing that we currently have.
Yeah. So, based on this, which areas of AI do you think will see the most immediate benefits of quantum computing? And are there any industry that are better positioned to adopt this first?
So actually, quantum computing is still in its infancy, right? So I don't want to create hype here. Currently, this is in a research mode, and currently, the quantum computing chips that we have few hundred qubits currently, and to make it scalable and make it application oriented, we need a few million qubits, yeah, on the processors. So I think it's still 5 to 10 years away, maybe 15 years away when we really see scale. But from the prototypes that what we see, we are feeling, and we have a sense that quantum computing, yeah, when it gets amalgamated with AI, will touch every aspect of human life. And as I said, from material science to logistics to finance to cybersecurity, to personalized medicine.
Yeah.
Yeah, it will touch almost everything
Oh,
that
industry.
comes
Yeah.
in play, because the way we compute, that changes. There's a paradigm shift which will happen. It is the way when we had those analog phones and then to the mobile phones, this shift from classical computing
Mm.
to quantum computing is even more bigger. Yeah,
Yeah.
this is a much bigger change. So currently, all companies and the interested startups are focusing on what are the technologies that they should use to get out of this challenge that we see in quantum computing right now, which is coherence.
Mm.
Which means that at the subatomic level, the interferences are such that the particles are not able to stay in coherence, and then they lose
Uh-huh.
their quantum states. So that's the current state. So I don't see immediately an application coming up. We may have to wait for a decade or so to see the real applications
Yeah.
coming.
Yeah. Yeah, we may have like years to wait until quantum computing can really like provide real world potential. So as promising as quantum computing sound, we know that there are significant barriers, hardware constraint, infrastructure challenges, and the lack of quantum ready talent. Aside from the one challenge that you mentioned earlier about the instability of the atomic level of quantum computing. So what step should enterprise take today to prepare for a quantum powered AI future, even if the widespread adoption is like still years away?
Yeah, I think what will happen is that there will be an in-between scenario situation
Mm.
wherein we are still using classical computing, but using a scenario wherein we have, say, quantum algorithms. Yeah, something like that will happen in the interim. And then, of course, the full-fledged quantum computing takes over when the quantum processors with qubits, get into production. Currently, I think the challenge for the industry is research oriented. Is that for quantum computing, basically you need to reduce the temperature of the setup to an absolute zero. Yeah, which is not easy task. Yeah, to do, and hence there is a lot of research is that what kind of subatomic particles we should use to gain quantum states. Should it be trapped ions? Should it be electrons? Should it be atoms? And now there is a lot of promise around topological qubits, yeah, which can attain quantum states at not absolute zero, but at temperatures which can be above absolute zero. So I think the focus for the next 3 to 5 years, as I see it, is that is more research oriented, and to see it is that how can we circumvent these difficulties on hardware and the ecosystem that we have. That's how I see it currently. So the focus currently is to create processors which are stable and which are coherent.
Yeah. So picking up on, like getting ready to for quantum future, and it's not I believe that it's not a technology that one organization can develop and adopt in isolation. It requires collaboration between enterprises, between research institutions, and also technology providers. Um, in your view, how critical is cross-industry collaboration in advancing quantum computing for enterprise AI?
I think for technologies like AI and quantum computing, intersectionality is very much needed. Yeah, and we already see a lot of collaboration between academia, between industry, between big companies, yeah, wherein there is a lot of say conferences, yeah, research dialogue, collaboration, sharing of information already happening. We have very large quantum networks across regions where the participation from the right stakeholders is already there, and I think it is expected and it is natural. That's how technologies progress. Technologies, if they are open source, I think create not only pull but also push to better ourselves. So quantum space is currently limited, but interest is heavy, and I think the start around collaboration is already good. I think the top universities in United States and in Europe and in Asia now already have some curriculum around what quantum computing is all about. Big enterprise company are already putting stake and resources into creating awareness and also investing in quantum computing space. And I think the big startups which are getting a lot of valuation these days, they may not have a quantum product ready, but have a quantum concept ready, but they are getting a lot of funding already.
Traction, yeah.
So I see there is initial activity in the right proportion, and I think it will be interesting because the benefits to humanity from quantum computing, I think is very meaningful.
Yeah. So yeah, this has been a fascinating discussion, Sudhir. And it's clear that while quantum computing is still emerging, its potential impact on enterprise AI is significant. So the road ahead may be uncertain, but for enterprise that want to stay ahead, understanding and preparing for quantum's role in AI is essential. So before we wrap up, do you have any final thoughts or key takeaways for businesses looking to navigate this transition?
I think businesses will continue to invest in any technology which makes life easier and enjoyable and better. And I think that's the track of human race. We always bet on progress and growth. So I don't see a situation where the interest in quantum will die down. So I'm optimistically cautious that this will continue to show progress. And as I said, in next 10 to 15 years, when the next generation comes in, I think the application of life will already be more interesting than what you and I saw.
Yeah, of course. Yeah. Thank you once again for joining us today. It has been a delight. And thank you to our audience for tuning in. So the future of AI and quantum computing is just beginning, and we look forward to seeing how this space evolves. So stay curious and stay informed.